Hello everyone. So in this video, I'm going to discuss JEE Mains 2024 1st February Shift 1. So first we'll see how many questions comes from which chapter and then we'll discuss the question. So in dimension, there is a one question from dimension analysis, and there is a one question from vernier caliper, and there is a question from error analysis, right? Relative error. And there is a question from kinematics about non-uniform acceleration, and there is a question from Newton's laws where we have to find the acceleration of the system. And there is a question from circular motion where they have utilized the concept of projectile as well as the circular motion together. In work power energy, there is a question where they have utilized the concept of conservation of linear momentum and then the conservation of mechanical energy. And there is a question where we have to find the center of mass of 2 point masses. And from gravitation, there is a question from variation of acceleration due to gravity with altitude. Elasticity, there is a theoretical question. And in Cartesian thermodynamics, there are two questions. One is for a mixture of gas, where we have to find the molar heat capacity at constant volume for that gas. And there is a question from polytropic process. In waves, there is a question from standing waves produced on a string fixed at both ends. And in electrostatics, there is a question on Coulomb's law. From current, there are three questions. One is from the current, and second is from the KVL, and the third question is the conversion of moving coil galvanometer into voltmeter. And then from capacitor, there are two questions. One is when we have two charged capacitor, if we connect them together, then what will be the loss of energy? And there is one theoretical question. In magnetism, there is a question from the magnetic field produced by a current carrying conductor. In alternating current, there is a question from resonance. And in ray optics, there is a question from lenses. And in wave optics, there is a question from diffraction. In atoms, there is a question from Balmer series. And in dual nature, there is a question from de Broglie wavelength. And from semiconductor, there is a question from Zener diodes. Now let us discuss these questions in this particular order. So first question is from dimension analysis. The dimension of angular impulse is equals to. So we know that angular impulse is nothing but the change in angular momentum. And angular momentum of a point particle is mvr. So we can use this formula, right? So mvr is, so it will be m raised per 1, l raised per 1, t raised per minus 1 times l. So this will be m raised per 1, l raised per 2, t raised per minus 1. So option 1 is the right answer. So again, very standard problem. Next question is from vernier caliper. A vernier caliper has 10 main scale division coinciding with 11 vernier scale division. So we given 10 main scale division. It coincides with 11 vernier scale division, and one main scale division is equals to 5 millimeter. Then find the least count of the instrument. So we know that the least count is the difference of the main scale division and the vernier scale division. So one main scale division is 5 millimeter, and one vernier scale division will be 10 by 11 main scale division. So that will be 10 by 11 times 5 millimeter. So from here, it will be 55 minus 50 by 11 millimeter. So it comes out to be 5 by 11 millimeter. So option C is the right answer. Next question is from error analysis. So we have given for measuring resistivity, the relation R is rho L by pi R square, where R is the radius of the conductor, is used to find the percentage error in the resistance, length, and okay, right. So percentage error in the resistance, length, and the radius are given as x, y, and z. Find the percentage error in the resistivity. So to find the percentage error, so in the resistivity, so rho is r pi r square by L. So we know that the relative error in the resistivity will be 2 times del r by r, delta r by r plus delta L by L plus delta capital R by capital R. Now if I multiply this with 100, we'll get the percentage error. Now the percentage error in capital R is X, and the percentage error in L is Y, and the error in Small r is z. So this will be 2z. So x plus y plus 2z. So answer option A is the right answer. Next question is from kinematics, where we have given position as a function of time, and we have to find the velocity when the acceleration becomes 0. So first let us find the acceleration. So first let us find velocity first. So velocity will be dx by dt. So that will be minus 9t square plus 36t. Now the acceleration will be dv by dt. So that will be minus 18t plus 36. Now we have to find the velocity when acceleration is 0. So you can clearly see that acceleration is 0 at t equals to 2 seconds. So velocity at t equals to 2 seconds will be minus 9 into 2 square plus 36 times 2. So this will be 4 9 is 36 plus 72. So the 36 meter per second is the answer of this question. Next question is from Newton's laws. A block of mass 20 kg is placed on a rough surface having coefficient of friction as 0.04 as shown. Find the acceleration of the system when it gets released. So first of all, let us find the limiting friction here. So limiting friction will be mu mg, right? So m in this case will be 20 and I'm taking g as 10. So this comes out to be 8 Newton, right? Now this 8 Newton is less than the 60 kg, right? 60 Newton. So this 8 Newton is less than the 60 Newton. So the system will go like this. So 6 kg block will go down and the 20 kg will slide in the right direction. So I'm assuming acceleration to be A. So we can, for this particular system, there is a 60 Newton force acting in the downward direction and there is a kinetic frictional force acting in the left direction. So we can say 60 minus 8 should be equals to 26 times A, right? So from here it will be 52 divided by 26. So acceleration will be 2 meter per second square, right? So option B is the right answer. Next question here basically from gravitation. A particle is moving, no, so not from gravitation, it is from a circular motion and the projectile motion. A particle is moving in a circle of radius r with a time period t. This moving particle is projected at an angle theta with the horizontal and it attains a maximum height 4r. Angle theta can be given as, so we have to find the angle theta of projection. And there is a particle which is moving in a circular path and the velocity, so tension is given to us. Let us say v is the velocity. Not tension, time period is given to us. It is not tension, time period is given to us. So time period is 2 pi r divided by v. So v is 2 pi r by t. So this is the speed. So in this question, it is not clearly mentioned, but here the particle is projected with the same speed. So we are projecting a particle with this speed at an angle theta, and it attains a maximum height which is 4r. So we know that h max, which is 4r in this question, will be v square sine square theta by 2g. And if I take the square root, so I can say 8rg root of that is equals to v sine theta. So v is 2 pi r by t sine theta. So if I take 2 pi r by t on the other side, we will get t by 2 pi r root of 8rg equals to sine theta. Okay, so if you look at the option, we have t and 2 pi outside or pi outside. Okay, let us take this 2r inside the square root. So t by pi root of 8rg upon 4r square. 1r will get cancelled out. So we have 2 in the numerator. So from here it comes out to be t by pi root 2g by r. So if I take the inverse of that, this will be the angle. So theta is sine inverse t by pi root of 2g by r. So option C is the right answer, right? Next question is from, you can say, energy conservation. First we have to conserve the linear momentum. A bullet of mass 10 raised to the minus 2 kilogram and velocity 200 meter per second gets embedded inside the bob of mass 1 kilogram of a simple pendulum. So there is a simple pendulum and this bob is having a mass of 1 kilogram, and there is a bullet which we have fired, and its velocity is 200 meter per second, and its mass is 10 raised per minus 2 kilogram, which is very small in comparison to 1 kg. Now after collision, what would happen? After collision, the bullet has embedded inside the bob, and it will acquire some velocity, right? Let us say that velocity is v. So first we can conserve linear momentum of the bullet and the bob system in the horizontal direction, because there is no force acting in the horizontal direction. So we can say 10 raised per minus 2 times 200 should be equals to 1 plus 10 raised per minus 2 times v. Since 1 is very large in comparison to 0.01, so we can eliminate, or we can simply write 1 plus 10 raised to minus 2 as 1. So v comes out to be 2 meter per second. So this is 2 meter per second. Now the bob and the bullet as a unit, they will move up, right? So this kinetic energy which they have acquired will be converted into the gravitational potential energy. Let us say at this height, the velocity becomes 0. So if you apply energy conservation, so we can say mgh, and here m will be the sum of the masses, and again I can ignore the mass of the bullet, and this should be equals to half m v square, 2 square, right? So m will get cancelled out, so no need to ignore, it will automatically get cancelled out. So this will be 2, so h will be 2 by 10, so which will be 200 by 10, so 20 centimeter. So 20 centimeter is the answer of this question. Yes, so next question is from center of mass. So two particles each of mass 2 kilogram are placed as shown in xy plane. If the distance of the center of mass from the origin is 4 root 2 by x, find x. Now we have two masses, two identical masses. This is 2 kilogram and this is 2 kilogram. And we know that the center of mass of these two particle system will be at the midpoint. So if if mass m1 is having coordinate 0, 4 and mass m2 is having coordinate minus 4, 0, the coordinate of the center of mass will be minus 2, 2, right? Now minus 2, 2 from the origin will be at a distance of 2 square plus 2 square by applying distance formula between the origin and minus 2, 2. So that will be 2 root 2. So this is given as 4 root 2 by x. So root 2, so x comes out to be 2. So 2 is the answer of this question. Next is a question, the length of a second pendulum if it is placed at a height 2r from the surface of the earth. Again, it is from gravitation, where the acceleration due to gravity changes as we go above the surface of the earth. And what is a second pendulum? A second pendulum has a time period 2 seconds, right? On the surface of the earth, a pendulum with a length 1 meter has 2 seconds as the time period. So if we go to an altitude which is 2r, so here this altitude is comparable to the radius of the earth, so we have to apply general formula. So at a, the acceleration due to gravity will be g upon 1 plus 2r by r square, so it will be g by 9. So the effective g will be g by 9, so we can apply time period formula, that will be 2 pi root L by g, so it will be g by 9. And this time is given as 2. So from here I can say pi root L 9 by g is equals to 1. And L is, and if I take the square, so 9L by g is equals to 1 by pi square, or we can say g upon pi square by 9 is equals to L, and the length is given as 10 divided by x pi square. Now this pi square will get cancelled out, and we have to find the value of length, right? X. So from here, if I take g as 10, then x will be 9, right? So 9 should be the answer of this question. Okay, so next question is from elasticity, and it is a theoretical question. So on increasing temperature, the elasticity of a material increases, decreases, remain constant, may increase or decrease. So as we increase the temperature of a substance, the bonding, or you can say the restoring force, decreases, right? So what would happen in that case? For the same amount of stress, the strain produced will be more. And we know that the elasticity will, which is nothing, so we measure elasticity by the modulus of elasticity. So I have a rod, so Young's modulus is stress by strain. So for a given strain stress, the strain will be more, so this will be more, so Young's modulus will decrease. So if it is, so we can say elasticity will decrease as we increase the temperature. Now next question is from Ketejian thermodynamics. So here we have to find molar specific heat for a constant volume and for a mixture of a gas. So we have a monatomic gas for 2 moles, 6 moles of diatomic gas. So we know that Cv for a mixture will be N1 Cv1 plus N2 Cv2 divided by N1 plus N2. So it is a weighted mean of the molar heat capacity at constant volume. N1 is 2, and for monatomic gas Cv1 is 3 by 2 R, and N2 is 6, and for diatomic gas Cv is 5 by 2 R divided by 2 plus 6, so that will be 8. So this 2 will get cancelled out. Here we get 3. So we have 15 plus 3. So 15 plus 3 is 18 by 8 times R. So this will be 4 and this will be 9. So this will be 2.25 R. So option 2 is the right answer. Now next question is from polytropic process. A gas undergoes a thermodynamic process from P1 V1 T1 to the state P2 V2 T2. For the given process PV raised to power 3 by 2, which is constant, find the work done by the gas. So here the polytropic coefficient is given as 3 by 2, and we know that the work done is given by N given by minus P2 V2 minus P1 V1 divided by A minus 1. Okay, so A is 3 by 2. So we can say it will be minus P2 V2 minus P1 V1 divided by 3 by 2 minus 1. So this is nothing but 2 times P1 V1 minus P2 V2. So option 4 is the right answer. Again, very straightforward question. Two strings are identical and fixed at both ends with the tension 6 Newton each. So there are two strings which are fixed at both ends and both have the same length 1 meter and same mass density, which is 1 kilogram per meter. Now what we have done, if the tension is changed from 6 to 52, so we have changed the tension of one of the string to 52. Then find the beat frequency. Okay, let us say this is a string 1, this is string 2, and for string 2 we have increased the tension from 6 to 52, and both the strings are vibrating in fundamental mode. And what is the formula for fundamental mode? It is V by 2L, where V is the speed of the transverse wave, and this V is nothing but the square root of T by mu. So 1 by 2L. So that is the formula of fundamental frequency. Now, as we increase the tension, the fundamental frequency of the second string will increase. So its frequency will be more than the first string. So we can say root 52 by 1 times 1 by 2 times 1 minus root 6 by 1 times 1 by 2 times 1. So that will be the beat frequency, right? So from here it will be root 52 minus root 6 divided by 2, and root 52 it is close to 7.3, and root 6 will be close to 2.6 divided by 2, and this will be around 4.7 by 2, so this will be 2.35. So this, our answer is quite close to 2.38, so option 1 is the right answer. So two identical, so next question is from electrostatics and it is from Coulomb's law. Two identical charged masses of density 1.5 gram per cc are suspended from two strings from a common point are in equilibrium in air at an angle theta with vertical. If the setup is immersed in water and the angle remains same, find K of the medium. Okay, let me just show you the situation. So we have two masses, identical masses, charged masses, right? So let us say the charge is Q. And let us say the angle made by both the string with the vertical is theta. So if I show the free body diagram of one of the mass, so there is a gravitational force acting which is mg, there will be a tension T, and there will be a Coulomb repulsion in this direction. Now the resultant of mg and the Coulomb repulsion will make an angle theta with the vertical. So we can say tan theta will be Fe divided by mg, right? Now if we submerge this setup in a liquid in water, and we have to find if the setup is immersed in water and the angle remains same, find K of the medium. So we have to find the K dielectric constant for water. So let us see. And we have given density, right? So density of both the charged masses is given to us. So when you submerge this, there will be a buoyant force, right? So if the volume is V, so I'm assuming V as the volume of both the charged masses. So there will be a buoyant force. So we can say the effective weight will get reduced. So this will be mg minus buoyant force, Fb, right? And there is a Coulomb repulsion, which will also change. It will become Fe by K, right? Rest of the things will remain same. The angle is also same. So we can say tan theta will be Fe by K divided by mg minus Fb. Now what is Fb? It is the weight of the liquid displaced. So density of water times g times the volume. And mass is nothing but density of the body times the volume. So if we equate first and the second, so we can say Fe by rho BV G should be equals to Fe by K divided by rho B. Sorry, not rho, it will be, yes, body race, rho B Vg minus rho W GB. So from here, Fe will get eliminated, even Vg will get eliminated, right? So we will get, so here we have K as rho B by rho B minus rho W, and density is given as 1.5. So this is 1.5 upon 1.5 minus 1, right? So this will be 1.5 by 0.5. So this will be 3. So you can remember this relation, right? So it's a quite standard problem. So you can remember this relation. So it comes out to be 3. So answer is 3. Now the next question is from current electricity, and it is here we have to find the reading of the ideal voltmeter. So we have given 8 identical batteries. EMF is 5 and the internal resistance is 1 ohm are connected as shown. Let us see. So let us say the current in this circuit is I. All the batteries are in the same order. So there are 8 batteries. So I can say if I apply KVL like this, so it will be 8 times E minus 8 times IR should be 0. So from here I comes out to be E by R, where E is 5, R is 1. So 5 ampere is the current in this circuit. And if I consider this battery cross which we have connected a voltmeter, the terminal voltage will be E minus IR. E is 5 minus current is 5 and resistance is 1. So this will be 0. So the answer will be 0 volt. Now the next question again is from current electricity, and we have to find the amount of charge passed through the cross section of the conductor in the interval from 1 second to 2 seconds. So I is given as 3t square plus 4t cube. So we can write I as dq by dt. So that will be 3t square plus 4t cube. Now we can use integration to find the charge. So if we integrate this from 1 to 2, so this will be 3t cube by 3 from 1 to 2 plus 4 t raised to power 4 by 4 from 1 to 2. So this will get cancelled out. 4 will also get cancelled out. So this will be 8 minus 1 plus 16 minus 1. So this will be 22 coulomb, right? So 22 coulomb is the answer of this question. Right. So the next question is again from current electricity, where it is from a conversion of a galvanometer into voltmeter. A moving coil galvanometer has a resistance of 50 ohms and full deflection current of 5 milliampere. The resistance needed to convert this galvanometer into voltmeter of range 100 volt. Okay, right. So when we have to convert a galvanometer into voltmeter, we have to increase the resistance, because we know that ideal voltmeter has infinite resistance. So we'll connect a resistor a very high ohms in series. So if this is our galvanometer, we'll connect a very high resistance in series. Let us this resistance is R. And for full scale deflection, it shows the maximum value. So if there is a current Ig, that is the full scale deflection current, the potential drop across this combination should be 100 volts. So I can say by Ohm's law, Ig times G plus R should be equals to 100. And Ig is given as 5 milliampere. So 5 into 10 raised to power minus 3, G is 50 plus R. So from here, this comes out to be 20. So R will be 20,000 minus 50. So it will be 19950. So option 1 is the right answer. Right. So next question is from capacitors. So find the percentage change in the capacitance if the potential difference across it is changed from V to 2V. We know that capacitance does not depends upon the potential difference. So there will be no change. No, so it will be 0, right? So there will be no change. A very basic question. Two capacitors are charged as shown when both the positive terminals of and the negative terminals of the capacitor are connected. The energy loss will be, okay, right? So you can directly use the energy loss formula. It will be half C1 C2 upon C1 plus C2, and then we have V1 minus V2 square. So here both the capacitors have the same capacitance, so this will become C by 2, and V1 minus V2 is nothing but V. So this will be CV square by 4. So CV square by 4 is the answer of this question. Suppose if we if in the same question, if we connect the negative terminal of negative plate of one capacitor with the positive plate, in that case this negative sign will be replaced with the positive sign. Right. So find the magnetic field at the center. So this question is from magnetism, and where we have to find the magnetic field by a current carrying conductor. Find magnetic field at the center of a hexagonal loop of total length 4 pi carrying a current of 4 root 3 pi. Okay, so we have given a hexagon, regular hexagon, which is having a current 4 pi. 4 root 3 pi. So this is the current. Okay, so first of all, if I consider any section of this hexagon, the magnetic field at the center will be into the plane, and by all these sections. So if I find the magnetic field by one section, if we multiply that by 6, we'll get the answer. And we know that if we have a current carrying conductor, finite conductor, and if we want to find the magnetic field at a point on the perpendicular bisector, if this angle is theta, then magnetic field will be given by mu naught I, and this distance is d, perpendicular distance is d, mu naught I 4 pi d 2 times cos theta, right? So this we can apply, or you can simply write this as mu naught I upon 2 pi d cos theta. So mu naught I upon 2 pi d cos theta times 6 will be the answer in this question. So and this d, so total length is 4 pi. So we can say it will be total length is 4 pi. So the side is a, let us say. So it will be 6 times a. So a will be 2 by 3 pi. and the perpendicular distance of the center from one of the side will be, it is the altitude of an equilateral triangle, right? So it will be root 3 by 2a. So root 3 by 2a will be root 3 by 2 by 3 pi. So that will be pi by root 3. So if I substitute the value, so this will be 2 times 10 raised to power minus 7, and d is pi by root 3, and cos 60 degree will be 1 by 2 times 6. So let me just, and yes, and the current value is 4 root 3 pi. So pi will get cancelled out. So this 2 will get cancelled out, and this then we have 3 times 6 times 4 times 10 raised to power minus 7. So this will be 18 times 4 into 10 raised to power minus 7. So it will be 7.2 into 10 raised to power minus 6 Tesla. So that should be the answer of this question. Now in the next question we have given, it's from alternating current. So in a series LCR circuit, if the capacitance is changed from C to 4C, how should the inductance be changed so that the circuit has same resonant frequency as before? So what is resonant frequency? It will be 1 by 2 pi root LC. Okay, so if I increase capacitance from C to 4C, the L will decrease by the same factor, so L by 4. So can you see what is the change? It will be L minus L by 4, so it will be 3L by 4. So L will change by 3L by 4. So option B is the right answer. So this next question is from ray optics. So distance between the virtual magnified image size 3 times of the object of an object placed in front of the concave lens, and object is 20 centimeter. So distance between the virtual magnified image and the object is 20. Okay, so the distance between the object and the image is given to us, and since we have a magnified image, okay, right, so I think there is some correction because concave lens can't produce magnified image, so it should be convex. Okay, right, so the focal length of the lens is x centimeter. Find the value of x. Okay, let us see. So we have given convex lens and there is an object, and let us say this is the image and this is the object, and this distance is given to us as 20 centimeter. Okay, so what I can do, I can take this as say x and this as y, and we have given y minus x as 20, and in lenses the magnification is given as v by u, where u is minus y and where v is minus y and u is minus x, and this is given as 3 because we have a erect image, so it will be positive magnification. So y is 3 times x, and we have given y minus x is 20, so we can say 3x minus x is equals to 20, and x comes out to be 10 centimeter. If x is 10 centimeter, y will be 30 centimeter. Now if you apply lens formula, so 1 by v minus 1 by u is equals to 1 by f. V is minus 30 and u is minus 10. So from here we can find the focal length. So LCM will be 30. So minus 1 plus 3 is 1 by f. From here focal length comes out to be 15 centimeters. So that should be the answer of this question. Next question is from wave optics, and it is from diffraction, single slit diffraction with slit of width 0.1 millimeter. Light of wavelength 6000 angstrom is used. A convex lens of focal length 20 centimeter is used to focus the diffracted ray. Find width of the central maxima. So in case of a single slit diffraction, and if we have given a convex lens in front of the slit, the d will be equals to the focal length of the lens, and we know that the width is given by 2d lambda by A, where D is the distance between the slit and the screen. In this case, it will be the focal length, lambda is the wavelength, A is the width of the slit. So 2, D is given as focal length, which is 0.2, lambda is 6000 angstrom, so 6 into 10 raised to power minus 7 divided by A, that is 0.1 into 10 raised to power minus 3. Now from here it comes out to be 2.4 millimeter. So option B is the right answer. Next question is from atoms and it is from Balmer series. So determine the lowest energy of photon emitted in Balmer series of hydrogen atom. So to have the lowest energy of the photon, it should be the first line of the Balmer series. And for the first line, the transition is from 3 to 2. So we can say it will be 13.6, 1 by 2 square minus 1 by 4, 3 square will be the energy of the photon. So 13.6, so this will be 9 minus 4, that will be 5, and 9 for 36, right? So from here it comes out to be 7.2. So 13.6 divided by 7.2. So that is slightly less than 2. So option B is the right answer. Next question is from dual nature. So de Broglie wavelength. So de Broglie wavelength of proton is lambda and that of the alpha particle is 2 lambda. So alpha, if proton has a mass m, alpha particle has a mass 4m. The ratio of the velocity of the proton to the alpha particle. So we know that de Broglie wavelength is lambda h upon the momentum. So it will be m, say v of proton, right? And 2 lambda is given as h upon 4 m v of alpha. Now if I multiply this by 2, so we can say h upon 4 m v alpha is h upon 2h upon MVP. So H will get eliminated, 4 will get M will get eliminated. So we have to find VP by V alpha. So that will be 8, right? So 8 should be the answer of this question. Now next question, or the last question of this discussion, is from semiconductors and it is from Zener diode. So in voltage regulator circuit shown below, the reverse breakdown voltage of Zener diode is 5 volt. So here the potential drop is given as 5 volt. Power dissipated across it is 100 milliwatt. So if power is given to us, we can find the Zener current. So Zener current will be the power divided by the potential drop across the Zener diode. So it will be 100 milli divided by 5. So this will be 20 milliampere. So 20 milliampere is the Zener current. Now what is the load current? So we know the potential drop across this. So the load current will be 5 divided by 1000. So which is nothing but 5 milliampere. So if this is 5 milliampere, this is 20 milliampere. But if I apply junction law at this point, this junction, the current here will be 25 milliampere. Now if it is 25 milliampere and here we have 5 volt, so across this resistor, the potential drop will be 3 volts. So we can say RS will be V by I. V is 3 and I is 25 milli. So I can take it in the numerator. So 1000. So this will be 1, then we have 25, 50, 20. So 120 ohms is the answer of this question. Right, so you have seen the question and the question difficulty is not that high. All questions were doable. So all the best for your last shift. Thank you.